In this video, we will be going over the answers to Grade 6, Chapter 9, Area, Lesson 2, Area of Triangles, Independent Practice, pages 677 through 678. Question number 1. Find the area of each triangle. The formula for area of a triangle is area equals 1/2 times the base times the height. Now remember, the base is the bottom, but sometimes when you turn a triangle sideways, it might not look like the bottom. But basically the base, you have to just pick one of the sides of the triangle and that will be the base. Then the opposite corner, if you draw a line perpendicular, that will be the height. So in our example, they've identified the base and the height for us. This is the base. And they've drawn a perpendicular line here. So that's going to be the height. So we can count the base. The base is 1, 2, 3, 4, 5, 6 units. So I'm going to write a 6 for base. And the height is 1, 2, 3, 4, 5, 6, 7, 8. So I'm going to write an 8 there. Now I am going to multiply . 1/2 times 6 equals 3. 3 times 8 equals 24. They didn't tell me what the units were in this problem, so I'm just going to write units because I don't know if it's inches or centimeters or millimeters or anything like that. So it's 24 units squared. Or you can write 24 square units. Now the reason why it is squared is because we have two dimensions. We have length, which we're saying is the base, times height. A dimension is something that you can measure. So we can measure length, width, and height, but we're only measuring length, in this case we're calling it base, and height. So that's two dimensions, and that is why we have a 2 here. 24 units squared. Question number 2. We're going to find the area of this triangle. Area equals 1/2 the base times the height. The base in this case is 24 8/10 of a centimeter, and height. They could record the height inside the triangle like they did on the last problem, but in this situation they drew it on the outside. Again, it's the distance from the bottom of your triangle to the opposite corner, and it is a perpendicular measurement to the base. So it can be written inside the circle, inside the triangle, or outside. So now we can write the numbers into our formula. Now we know because of the commutative property that we can switch numbers around in a multiplication sentence. So I could actually write it like this: 1/2 times 16 times 24.8. And then I could multiply 1/2 times 16, which half of 16 is 8. Now we can multiply 24.8 times 8. 8 times 8 is 64. 8 times 4 is 32, plus 6 is 38. 8 times 2 is 16, 17, 18, 19. I have 1 decimal and 1 decimal. So the area equals 198 and 4/10 centimeters squared. And see, I have the base's measurement and the height's measurement. There are 2 dimensions, base and height, so I wrote a 2. 198.4 centimeters squared. Question number 3. We're finding the area of this triangle. Area equals 1/2 times the base times the height. Now, the base is the side that we consider the bottom. Even though it might actually not appear on the bottom, it is perpendicular to the height. So in this case, 41.5 is going to be our base. And then perpendicular to that, we will find the height, which is 36 feet. So we can write these numbers in our formula. Now I'm going to write them out of order only because, well actually I won't, because I want to stick to what we're talking about. 41.5 feet times 36 feet. Now remember, you can always change the order of a multiplication problem, so I'm going to write it like this. Because at first I'd like to find out what 1/2 of 36 is. So 1/2 of 36 equals 18, and I can do that mentally. So I like to do the mental parts that I can get done first. Times 41, and this is written as a fraction, but I can write half as a decimal, so I'm going to choose to do that because it is a little bit easier to multiply by. So we have 41.5 times 18. 8 times 5 is 40. 8 times 1 is 8. 9, 10, 11, 12. Carry the 1. 8 times 4 is 32, plus 1 is 33. I'm done multiplying by the 8. I add a 0. 1 times 5 is 5. 1 times 1 is 1. And 1 times 4 is 4. So I add these numbers together. 5, 6, 7. 3, 4. 4, 5, 6, 7. Now I had 1 decimal place in my problem, so I'm going to have 1 in my answer. So the area equals 747 feet squared. Question number 4. Find the missing dimension of each triangle described. Well, for question number 4, they've given us a height of 14 inches for the triangle and an area of 245 inches squared. Here is our formula for finding the area of a triangle. Area equals 1/2 times the base times the height. Now we plug in the information that we know. We know that the area is 245 inches squared. And we can now bring down the 1/2 times the base. They do not give us the base here, so that is what we are trying to figure out. So we're going to keep the variable b for right now, times the height. They have provided us the height. The height is 14 inches. Because of the commutative property of multiplication, I can rearrange my numbers. I can write now 245 inches squared equals 1/2 times 14 inches times the base. This would equal 245 inches squared equals 1/2 times 14 equals 7 inches times the base. In order for me to find out what b is, I need to get it alone on the right side of the equal sign. To do this, I have to get rid of 7 inches. I'm multiplying by 7, so I have to use the inverse operation, which is division. I'm going to divide both sides by 7 inches. 7 divided by 7 is 1, and 1 times b equals b. Now I have to divide 245 by 7. 7 is unable to divide 2. It can divide 24 3 times. 3 multiplied by 7 equals 21. 4 take away 1 is 3, and 2 take away 2 is nothing. Now I bring down the 5. 35 divided by 7 equals 5. 5 times 7 equals 35, and I have 0 as a remainder. So the answer is 35. Now I'd like to highlight my units so we can discuss what's happening here. I'm going to get my highlighter to highlight what I'm talking about here. I have inches squared divided by inches, and I'm going to use a different color over here to show you this. I have inches, oops, that's yellow, sorry. I have inches squared divided by inches. Well, we know that when we square something, it means that that item or number is multiplied by itself. So inches squared really is inches times inches divided by inches. Well, the top inch and the bottom inch cancel each other out, which leaves me with just 1 inch. This translates into inches. So that's how we get inches and not inches squared as our answer. And that makes sense because the base is a linear measurement. We're just measuring a line, and that is just one dimension. So the answer is 35 inches. Question number 5. Find the missing dimension of each triangle described. In this example, they have given us the base, which is 27 centimeters, and they've provided us with the area, which is 256.5 centimeters squared. Our formula is area equals 1/2 times the base times the height. I'm going to plug in the area for A, which was given to me, 256.5 centimeters squared, equals 1/2 times B. B is the base. They provided that to us. It is 27 centimeters times the height, which I do not know. That's what I'm solving for. So I have 256.5 centimeters squared equals 27 divided by 2 equals 13.5. times h. Now to get h by itself on this side, we need to get rid of multiply by, I'm getting my highlighter here. We need to get rid of multiplying by 13.75. Now, how do I get rid of multiplication? I need to do the inverse operation, which is division. So I'm going to divide now by 13.5 centimeters on both sides. Okay, so 13.5 centimeters divided by 13.5 centimeters equals 1, and 1 times h equals h. Now, on the left side, I have 256.5 divided by 13.5. At this point, I would recommend putting this into a calculator. You absolutely can do it by hand, but it's okay to put it in a calculator as well. So take a moment, put that in a calculator. When you do this, you should have gotten the answer 19. So we have 19 as our number answer. Now we need to take a look at our unit answer. I'm going to highlight that here in blue. Blue's a little dark, sorry about that. Okay. So again, this is centimeters squared. This is centimeters squared divided by centimeters, which equals centimeters times centimeters over centimeters. So I can cancel one off the top and one off the bottom, and that's going to give me centimeters. So my unit will now be just centimeters, which makes sense because the height, here's my triangle, my height is just a linear measurement. It's just one dimension length, okay? So that's why I only have a 1. Now I just want to tell you, centimeters to the first power is the same thing as centimeters. In math, we just like to get rid of any unnecessary things, so the 1 is assumed. So your answer is 19 centimeters. Question number 6. Ainsley is going to help his father shingle the roof of their house. What is the area of the triangular portion of one end of the roof? So we have a little drawing here, a little model, and it is a roof, okay? And I see that they provided me with a base, which is 7, and then the height is going to be 4. So let me get my formula. Area equals 1/2 the base times the height. So we don't know the area, but we have 1/2 times the base, which is 7 yards, times the height, which is 4 yards. Again, I can, because of the commutative property of multiplication, rearrange my problem. And this time I've just completely rearranged it, but that's okay because I can do that because it's a multiplication problem. So I'm going to multiply 4 yards times 1/2 first. 4 times 1/2 is 2 yards, times 7 yards. And I do have to tell you that S I shouldn't have written. That's not really official. Okay, and so area equals 2 times 7 equals 14, and yards by yards equals yards. Made 2 mistakes, sorry. Equals yards squared. So the answer is 14 yards squared. Question number 7, multiple representations. The table shows the areas of a triangle where the base of the triangle stays the same, but the height changes. So let's look at this table that they've given us. They said that the table shows the areas of a triangle where the base stays the same. And if we look, we see that the base is 5, 5, 5, 5, and 5. And the height is going to change. All right, so the height changes. So our height goes from 2 to 4 to 6 to 8, and then we have a mystery number here. And then we have our areas, 5, 10, 15, and 20, which makes sense because my height is increasing, therefore my area should increase. Now I'm going to erase this just so I have a clean page to work with here. All right, so let's take a look at what these would look like. Okay, so for the very first triangle, we were told that the base is 5, so I'm going to draw that with a red line. The height is 2, so I'm going to go up 2 and create a triangle, which will look like this. So if we counted it, the area would be 5. Now, for my next triangle, I also have a base of 5, but this time the height is 4, which would look like this. And the area is 10. So I go to my next triangle. This has a base of 5, a height of 6, and an area of 15. And then my next triangle has a base of 5, a height of 8, and an area of 20. Our question here is this. Write an algebraic expression that can be used to find the area of a triangle that has a base of 5 units and a height of x units. When I look at this table, I know that 1/2 times 5 times 2 equals 5. 1/2 times 5 times 4 equals 10. 1/2 times 5 times 6 equals 15. 1/2 times 5 times 8 equals 20. 1/2 times 5 times x equals what? So we go back to our original formula, area equals 1/2 times the base times the height. So the area is going to equal 1/2 times 5. For the height, they're going to give us the variable x, so I'm going to write x. Now, I think it's important to see what the answer is in this case, so I can show you how they got this answer. The answer is 5 times x divided by 2. And how did they get that as the answer? Well, I have 1/2 times 5, and 5 is a whole number. So I can write that as 5 over 1. I can actually write x over 1 as well. So now 1 times 5 equals 5, and 5 times x equals 5x. Now I have 2 times 1 equals 2 times 1 equals 2 again. So this is how they got 5x equals 2. Now I would also put a, but they're just having you write the answer. All right, question B, graph. Graph the ordered pairs, height, and area. Now I'm going to erase again, so give me a sec here. They just want us to graph the area and the height. Now they listed height first, so height is going to be my x, and then area is going to be my y. I'm going to change my colors here. The coordinate pair would be 2, 5, 4, 10, 6, 15, 8, 20. So let's graph that. If you graph that correctly, you should have something that looks like this. We have 2, 5, 4, 10, 6, 15, and 8, 20. Now, unfortunately, they made you really estimate here, but that's because it increases significantly, but we only have a little bit of space on our worksheet. So now, describe the graph. So what does this graph create? The points appear to form a line, and there is your line. Question number 8. What is the area of the triangle on the flag of the Philippines in inches? Explain your reasoning. All right, now this is a challenge question, and the reason why is because not all of my units are in inches. So here we have inches, okay, but here we have feet, and here we have feet. So the very first thing we need to do is to convert the feet into inches. So we know that 1 foot equals 12 inches. So 3 feet equals how many inches? Well, to get from 1 to 3, I have to multiply by 3. So then I'm going to do the same thing over here. I'm going to multiply by 3. And that will give me 36. So 3 feet equals 36 inches. And just for the heck of it, I'm going to do this one down here. We know that 1 foot equals 12 inches. 5 feet equals how many inches? Now, I went from top to bottom here, but you can also go from left to right. 1 times 12 equals 12. So 5 times 12 equals 60. So the length of our flag is 60 inches, and the width of our flag is 36 inches. Now they're asking for the area of the triangle, and the triangle is right here. And I'm going to change my color so I can highlight it for you. The triangle is right here. All right, and then right here, and then right here. Okay. So we know that the formula for the area of a triangle is the area equals 1/2 the base times the height. So I have area equals 1/2 the base. So the base of my triangle is here, but I don't see a measurement. Well, I know that this is a parallelogram, the rectangle, and opposite sides of a parallelogram are congruent. So if this side is 3 feet, sorry, this is a terrible line, 3 feet, then this side is 3 feet. Now I'm going to stick with inches, so if this side is 3 feet, it's 36 inches. So I'm going to write that down, 36 inches times the height, and the height is indicated with this dotted line that is perpendicular to the base. So we have 30 inches. All right, now I can solve. Area equals 1/2, of, I'm going to go back, sorry, 1/2 of 36 equals, change my color of my pen back, equals 18. So I write 18 inches times 30 inches. And we have 18 times 30, 0. 3 times 8 is 24. 3 times 1 is 3 plus 2 is 5. So area equals 540 inches by inches is inches squared? The answer is 540 inches squared, and your sample answer would be the base of the triangle is 3 feet or 36 inches. The height is 30 inches. So the area is 1/2 times 36 times 30, or 540 square inches. Question number 9. Find the error. This is a hot problem, higher order thinking. Dwayne is finding the base of the triangle shown. The area is 100 square meters. Find his mistake and correct it. Well, if you're looking carefully, we know that the area equals 1/2 times the base times the height. So here we have the height is 20 meters, which he wrote, and we were told that the area is 100 meters, which he wrote, and the base he wrote. But he's missing the 1/2 part. So what he did was he actually found the area of a rectangle, okay, not the area of a triangle, because the triangle would be cut in half. The formula is 1/2 times the base times the height, not the base times the height. So if he did it correctly, 100 equals the base times the height divided by 2. Because remember, 1/2 is the same thing as divided by 2, or just divided by 2. And that would give us 10 meters. Question number 10. Persevere with problems. How can you use triangles to find the area of the hexagon shown? Draw a diagram to support your answer. Now I want us to go back and think about when we were finding the area or figuring out the formula for the area of a triangle. What we did was we figured out for a parallelogram, which is a rectangle, that the area was base times height. But for a triangle, then we would divide that in half, okay, because this would be half of the triangle. I'm sorry, half of the rectangle is the triangle. So how might we divide this into triangles? Think about that. Well, I'm going to give you a little tip here. It starts right here. If I put a dot right here, what might I be able to do? Think of a pizza pie, right? We can like divide this up into triangles. So it would look like that. The sample answer is, the hexagon is formed by 6 congruent triangles. Now congruent means that they are the same size and the same shape. If the hexagon is divided into 6 triangles, find the area of one triangle and multiply by 6. Question 11. Identify repeated reasoning. Draw a triangle and label its base and height. Draw another triangle that has the same base, but a height twice that of the first triangle. Find the area of each triangle, then write a ratio that expresses the area of the first triangle to the area of the second triangle. Now, this may seem like a very wordy problem, but let's break it down into its parts, okay? So I'm going to get my highlighter here, and let's do the very first thing. It says draw a triangle and label its base and height. Okay, we can do that. Now, just so you know, the easiest triangle, when they say to draw a triangle, don't draw a complicated triangle. Remember when we were talking about parallelograms? If they say draw a parallelogram, draw a rectangle, because it's simple and easy to work with. Well, another simple triangle to draw is a right triangle. The reason I say this is because the height is one of the sides, okay? So that's super helpful. All right, so anyway, we drew a triangle, and its base is 12 and its height is 4. So that's what they asked us to do. Now, let's go to the next part. It says draw another triangle that has the same base but a height twice that of the first triangle. Okay, well, I know, I'm changing my colors here, that, all right, so it's going to have the same base, so the base is going to be 12, but I have to double my height. So my height is 4, I'm going to double it, and that's going to make it 8. So now I have a triangle that looks like this. All right, next part of my question, I'm going to go with green, highlighter. All right, whoops, that's a blue highlighter, sorry guys, green. All right, find the area of each triangle. So let's do that. So we have, for our smaller triangle, we have the area equals 1/2 times the base times the height. So the area equals 1/2 times 12 centimeters times 4 centimeters. So the area equals 6 centimeters times 4 centimeters. So the area equals 24 centimeters squared, because it's centimeters by centimeters. Now, for our second triangle, we have that the area equals 1/2 times the base times the height. So the area equals 1/2 times 12 times 8, and these are centimeters. So the area equals 6 centimeters times 8 centimeters. So the area equals 48 centimeters squared. All right, we haven't used orange. Oops, sorry, highlighter. And I need to change the highlighter to orange. Then write a ratio that expresses the area of the first triangle to the area of the second triangle. All right, so here's what we've got. And I need to do a little bit of erasing so I can clearly see what I've written. Sorry about that. And I'm going to actually move that up so I can stay consistent here. So the area equals 48 centimeters squared. All right, so what's our answer here? Area of the first triangle is 24 centimeters squared, which we have. The area of the second triangle is 48 centimeters squared, which we have. So it's 1 to 2, or 1/2. So let's go back here. Write the ratio that expresses the area of the first triangle to the area of the second triangle. So we have 24 to 48, and then it equals 1/2. Okay, or we could have written 24 to 48, which is 1 to 2. And that goes back to our very first chapter on ratios. Question 12, reason inductively. The triangle shown has an area of 8 and 15/16 square feet. What is the height in inches? So we have our formula, area equals 1/2 times the base times the height. So our area is 8 and 15/16 feet squared equals 1/2 times the base, and the base is 5 1/2 feet, 5 1/2 feet times the height. Now we're going to use a calculator for this. So in your calculator, type 1/2 times 5 and 1/2, and you should get 2 3/4. Oops, sorry. Let me go back here. Eraser, pen, 2 3/4 feet times the height. And that equals 8/15/16 feet squared. Now I'm going to divide both sides by 2 3/4. Divide both sides by 2 3/4 feet. Okay, now that cancels each other out on the right, so I have an h for height left. And in your calculator, you're going to do 8 15/16 divided by 2 3/4 equals, and you're going to get 3, write this 3, and hold on one sec. And 1/4 Now again, we had feet squared over feet, right? So that equals feet times feet over feet. So that crosses out. So now I have feet, all right? So we have 3 1/4 feet for the height. But now we want to convert that to inches. So I know that 1 foot equals 12 inches. So to go from 1 foot to 12, I have to multiply by 12. So I'm going to have to multiply by 12 here. So multiply by 12, and you're going to get 39 inches.